In this video, we are going to see about Aloha as well as CSMA. Aloha as well as CSMA. So the media access control is divided into three types called as a random access protocol, controlled as well as channelized protocol. So in this video, we are going to see about random access protocol, and the random access protocol is divided into Aloha as well as CSMA. So what is random access protocol? So all the stations has the same superiority, that is no station has more priority than the other station, which means that each and every station is responsible for sending the data to the medium, okay, at the same time. Okay, it may be ideal or it may be busy. So the two features is no fixed time for sending the data to the medium, as well as there is no fixed sequence for the station sending the data. So the random access protocol is further divided into Aloha, CSMA, right? So Aloha is classified into two types. First one is pure Aloha and the next one is known as slotted Aloha, right? So what is Aloha? So it is designed especially for wireless LAN, but it is also applicable for shared medium, right? So the multiple stations can transmit the data at the same time and can hence lead to whole collision and the data being grabbed, right? So when transmitting the data to the medium at the same time, automatically collision happens, right? So what is pure Aloha? You can see from the diagram, there are four stations at the same time. Okay, you can see here at the same time we are going to send the packets, right? So station 1 is sending the packet called as frame 1.1 and it waits for the acknowledgement. So if the acknowledgement does not come back within the allotted time, then the station waits for the random amount of time called as back of time, called as TB, right, and resends the data. So since the different stations wait for different amount of time, the probability of further collision decreases in pure Aloha. But what happens here, when station 1 is sending the frame called as frame 1.1 as well as frame 1.2 as well as frame 1.3, so you can see here where collision is going to happen at the same time. Okay, station 2 is going to send the frame called as frame 2.1 and station 3 is going to send the frame called as what, 3.1. So all these things comes under the same slotted time, right? Automatically there will be collision between these four packets, right? And you can see here also you can see here 1.3, 2.2 as well as frame 3.2 comes under the same slotted time. So automatically collision happens here in pure Aloha. So in order to avoid this, slotted Aloha is been introduced. So it is somewhat similar to pure Aloha, but we are dividing the time into different slot and sending the data allowed only at the beginning of this slot, right? So if the station misses out the allowed time, it must wait for the next slot, right? You can see here. So each and every slot in this diagram is marked by means of a red line. Only in these slots we can send the frame from one station to another station in the same medium. So you can see here the time is same for each and every station, right? So the collision happens. Okay, we cannot say that the collision will never happen, right? Station 1 is going to send the frame called as 1.2 at the same time. Station 3 is also going to send the frame called as 3.0 at the same slot. So automatically what happens? Collision happens here, right? So in order to avoid this, the next method called as carrier sends multiple access is been introduced called as CSMA. This CSMA is divided into four types: one persistent, O persistent, non-persistent as well as P persistent, right? So what is carrier sends multiple access? In order to reduce the collision, okay, between the station who is sending the frame, okay, in ideal or busy state, okay, so we are introducing a new thing called as CSMA. If it is ideal, then it can send the data, otherwise it will wait till the channel become ideal. So the collision is probably going to be reduced by means of CSMA called as carrier sends multiple access, right? So So however, by the time the first bit of data is transmitted from station A, if station B requests to send the data and sends the medium, it will also find it ideal and will also send the data. So this will result in the collision of the data from station 1 or station A to station B. So now you can see the diagram of one persistent. This one persistent will continuously check the medium. So you can see here the channel is continuously checked or sensed to transmit the data, right? So if the channel is busy, they are not going to send the data. When one persistent find the channel is free or in ideal state, then the next station is going to send the data, right? So it is going to continuously check. So that is what we are showing the arrow mark like this. It is going to continuously check the medium, and when find the ideal channel, it will send the data. So this will avoid the collision. The next thing is non-persistent, which means that it is not going to check the medium or the channel continuously. Okay, if ideal, it will send the data, otherwise it will check the medium at the random amount of time, which means not continuously going to check, right? So you can very well see in this diagram, they are continuously sensing the channel at the random time, and when find the channel is free, it is going to send the data. The next thing is called as P persistent. So P persistent has some time slot. So in this line time slot, it is going to sense the channel, okay, continuously sense at the time slot, and in each and every interval it is going to send the data, and this can be used to avoid collision in the medium. And the last one is known as O persistent. There will be a supervisory node which is decided beforehand, and the transmission occurs in an order. If the medium is ideal, the node waits for it and the time slot to send the data. This is how it's going to work for O persistent. So in this video, we have discussed about the random access protocol called as Aloha, Pure Aloha, Slotted Aloha, CSMA, one persistent, O persistent, non-persistent, as well as P persistent, right? So thank you for watching. See you in the next video. Thank you.